In this question, you have to sketch f dot dot 0 to 6 inclusive mapped onto R, where f of x is equal to this absolute value function. And a real quick way of sketching this to give you an idea of what you're going to get is just to do this. So there's the x and y axis. The absolute value of x is just something like that, passing through naught, naught like that. This minus 3 is a sideways shift to the right by 3. So you're going to get that, the graph becomes that, and then this moves that graph up too. So it's going to be something like that. That's roughly what your final graph's going to look like, except it's going to start at x is 0 and end at x equals 6. So it would really start there, go down to some point here, and then up to where x equals 6. So that's what you're going to end up with by doing it in a more accurate way. So, and the way you do it is to start by splitting this into two separate functions. So really it's becoming a hybrid function. So you just take what's in the absolute value brackets, if you like, the x minus 3, and then add the 2, and you want this part to be positive, and it's going to be positive if x minus 3 is greater than 0, and from there x would be greater than 3. So for example, if x was equal to 4, 4 minus 3 equals 1, and so 1 is positive. So tidying that up, you get x minus 1, and that's the first function you're going to have to sketch. The second one, you're just going to do the minus of what's in the absolute value function. So the minus of x minus 3, and then plus the 2, and that's going to be for x, or the opposite of these values, which is x less than or equal to 3. So if you pick any x value less than 3, like 0, 0 minus 3 equals minus 3, and then that minus out the front makes that minus 3 a positive. So that's how that bit works, and you get minus x plus 3 plus 2 is plus 5 for those x values. And so that's what I've got to sketch here for that domain, and that for that domain. Now, the quick and easy way of sketching it is to start with x equals 0. So if x equals 0, then you would sub it into this function here because you want x values less than or equal to 3. So subbing x equals 0 in here, you get 5. So y, I'll just do the steps. So minus x plus 5, so equals 0 plus 5. I'll actually do the 0. 0 plus 5 equals 5. Therefore, you end up with the point 0, 5. The next point I want to look at is if x equals 6. And that I'm going to sub into this function here because it has x values greater than 3. So y equals x minus 1, 6 minus 1, which equals 5 also. So therefore you get the point 6, 5. And then the other thing is that this value of x equals 3, that's where these two linear functions meet. So that x value, all you have to do is just let x equal 3, and if you sub it into the top function, x minus 1, you get 3 minus 1, which is 2. If you sub it into the other function, you get y equals minus x plus 5. So that becomes minus 3 plus 5, which is 2. So either way, you get the point 3, 2. So those 3 points here, 0, 5, 6, 5, and 3, 2, all belong to this absolute value function graph. So drawing the axes, first of all, 0, 5 is here, and then 6, 5 is over, and then 3, 2 is here. And then connecting those three with straight lines like that. Now, these are not straight as in a straight line with a ruler, but we'll just pretend they're straight for the time being. So there's the graph, and all you would have to do from here is label those endpoints, so 6, 5, and this point here as well, 3, 2, and then this one here, 0, 5. And there's the graph. That's a real easy way of doing this kind of graph when the domain is restricted like this, because you are finding the endpoints straight off and then you're finding this point where the two lines meet. So there is the graph of this function for this domain. Now, this time I've added a couple of elements to the same question. I've put a minus in front of the absolute value function, and I've also made a round bracket here on the domain. So again, just a quick sketch of what you're going to end up with. So x and y axis. So the absolute value of x is here, something like that. Minus 3 shifts it to the right 3. Then that minus reflects it in the x-axis, so it makes all the y values opposite of what they were. So it goes down here like that, and then now the whole graph's moved up too. So you're going to get something like that from 0 to 6. So it would be from there up to there down to about here. So that's what you're going to end up with, something like that. So you pretty much do the same steps. It just gets a little bit trickier with this minus here. So this is how you do it. So start off with y equals, and then you're going to have minus, you're going to have that minus and then just keep that as it is in there. So it's going to be this plus the 2 for all of those values in there, or all of values in there being positive. So that's going to work out to be x greater than 3. I'll put the step in for you. So x minus 3 you want to be positive. So x is going to be greater than 3. And then tidying this up, you get minus x minus minus 3 plus 3 plus 2 is plus 5. And for the second part, you want to do, so this minus is that minus that's outside, and then you're now going to do the minus of what's in there. So minus x minus 3, and then plus 2, and that's going to be for x less than or equal to 3. So this becomes a plus, and then you've got x minus 3 plus 2, so you've got x minus 1. And that's for x less than or equal to 3. So underlining the bits that I've got to draw or sketch. First of all, subbing in x equals 0, so if x equals 0, y is going to equal, so it's this one here you've got to sub it into, so y is going to equal minus 1. That's a pretty straightforward substitution. So I'm not going to show you the steps. So here you get 0, comma, minus 1. If x equals 6, then you're going to sub 6 into this function here because you want x values greater than 3 for this part. So you get y equals minus 6 plus 5, which is minus 1. Therefore you get 6 comma minus 1, and then this value of 3, that's where the graphs are going to meet. If x equals 3, so x equals 3, then I'm going to pick this equation, minus 3 plus 2, minus 3 plus 2, that's plus 5, and then that equals 2, and you get the same thing if you put 3 in here. 3 minus 1 is 2, so therefore again that point 3 comma 2. So setting up the graph, there's the graph or the axis setup and plotting these 3 points. So 0 minus 1 goes here, 6 minus 1 goes here, and then 3, 2 goes there, and then it's just a matter of joining those 3 points. So I'll do that for you now. Like such, this one's got a bit of a wobble in it. They're not perfectly straight, but you get the idea. So there's that point here. So just checking this domain again. This is a square bracket, so this point here where x is 0 is definitely included. Round bracket here, so the value 6 is not included. So this here really needs to be an open circle. There's no really about it, it has to be. So for you to get it correct. So open circle there, and then this here is the point 3, 2. So labeling all the points again, so 6 minus 1, and then 0, minus 1, and there is that graph. The trickiest part, I think, is this part in here, making sure you get the minuses right, and other than that, you just actually getting this part right. So once you've got that, it's just a straightforward matter again of subbing in x values to the correct part. That's the key part you've got to make sure you do, and you always check with the domain as to which part to sub the value in, and then setting up your graph and then drawing it, and that's pretty much it. And then also paying attention to your domain here. Always got to keep an eye out for whether the interval has round or square brackets and mark your graphs accordingly. So that's about it for this lesson, and I'll see you in the next one.